Hope we could start today's session. Good morning, everyone, and a warm welcome from Congress Study Circle. And I would like to welcome our guest speaker, Maitra. Hi, Maitra, can you switch on? Yeah,
Hi.
yeah.
Yeah. Hi.
Hi. So he's a BE civil engineer, and he had done his master's ME in dredging and marine engineering. Very peculiar and special UG he had. And while I'm talking with you, I could able to understand that it was fascinating what he does and what kind of role is this. Both is challenging and fascinating together. We are very much happy to have you, Maitra. Actually, you are waiting for us for the past 1 month to get the session.
Right.
We have not we don't know each other before, but
Right.
having introduced with a common friend to us, you just agreed for this. On behalf of Congress Study Circle and all our friends, we are very much thankful to you. Thank you so much, Maitra, for accepting our request and spending a lot of time on preparation and your busy schedule. You came all here in Saturday evening to share your knowledge. Thank you so much, Maitra.
Yeah.
And this is for you. You can take session is yours.
All right. Fine. So first of all, Rajan, thank you. Thank you for this opportunity. I was really.
Maitra, 1 second.
Yeah.
Is Maitra is audible to you all?
Yes, sir.
Maitra, please carry on. Yeah.
All right. First of all, Rajanji, thank you for calling me. Now, first of all, I would like to apologize to everybody. I'll start off. The session was scheduled yesterday, but due to some work commitments, I could not be available. So at the last moment, I had to inform Mr. Rajanji that it will not be possible yesterday. So he agreed gracefully that we can do it today. So a little bit about myself. As Rajanji said, BTech Civil Engineering. I did MTech in Dredging and Harbour Engineering. Right now, I'm in Bangalore. I'm working with a design consultant. And finally, I'm from Calcutta. So the entire session, it's going to be in English, Hindi, and if somebody knows Bengali, please interact in Bengali. No problems there. So I'll just begin off and I'll share my screen and I'll begin the presentation directly. So just a minute. Yeah, is my screen visible to everybody?
Yes, sir, visible.
Okay, perfect. So the topic, I think, as discussed with Mr. Rajendran, was that marine engineering challenges and the way forward. I think I'll do one thing. I will switch off my video. That way there will not be any lag in whatever I say, right? For the duration of the, PPT, I'll stop the video. So, right. So as discussed,
Can you make it full screen, Maitra?
It is at full screen right now.
No, we are seeing it and it is not there in a slideshow mode.
It is in slideshow right now for me.
Can you please just once close it off and again reopen?
Yeah, fine. Just a minute.
Yeah.
Is it better now?
Perfect. Please proceed.
Okay, fine. So I'll start from the beginning. So the first thing is that marine engineering, the topic of today's discussion is basically going to be marine engineering challenges and the way forward. So I have kept it as introductory as possible. I am told that most of you are not from marine background. So whatever I'm going to say is going to be very new to you. So we will go to the challenges and way forward, but I have spent a lot of time in crafting a PPT that will help you understand and give a introduction to marine engineering as a whole. Okay. So first of all, let us begin with what is marine engineering. So marine engineering, as the name suggests, marine is anything related to water. So water, sea, oceans, these form about 75% of Earth's surface, right? And we have a lot of cargo movement that happens in the entire oceans and the seas. So the primary objective of marine engineering, be it 2000 years back or 4000 years back, was that cargo had to move from point A to point B. And for that movement, all the basic infrastructure that one needs to develop, basically, it can be roads, it can be ports, it can be ships, it can be a coastal structure, whatever it is, had to be made for movement of cargo. So essentially, marine engineering is the design, construction, and maintenance of structures that are in coastal and marine environments. So be it any structure that it can be, if you are designing it, constructing it, or maintaining it, there are certain codal provisions, there are certain aspects that you have to keep in mind, and that entire scope is under marine engineering. All right. So let's move on to the next one. So what is the scope of marine engineering? So marine engineering has like many parts. Okay, I have just tried to narrow it down as much as possible. So 2000 years back, we only were moving cargo from point A to point B. But 2024, we are having a lot of technologies now. We have come up with many opportunities, many things. So these are the fundamental 5 rules or fundamental 5 pillars that marine engineering encompasses, right? The first is naval architecture and ship design. So essentially, if you see that any ship that is made or any ship that is moving, however big it is, however complicated it is, however small it is and simple it is, needs to come out of a design sheet. Just like how 2D and 3D drawings are made, similarly, for every ship, you will make a design. Okay, so that is your naval architecture and ship design. Second part is marine structures design. Third is design, dredging and harbor works. Fourth is marine power generation. Fifth is ship and cargo movement. Okay. So I had started explaining naval architecture and ship design. So as I said, it can be as complicated as an aircraft carrier or as simple as a 1000-ton barge. Every ship will have plan, section, elevation drawings, just like we have in a building or in a bridge or in any part, right? So this entire discipline is under naval architecture and ship design. Next is marine structure design. So marine structure design is from a civil engineer's perspective, it is very critical and important. So we have 2 types of structures that are essentially part of this. One is coastal structures, second is offshore structures. So standard thumb rule of understanding this is any structure that is along the length or along the vicinity of a coastline. That is, there is a beach and you're constructing something around the beach. That is a coastal structure. Any structure that is in deep sea, it can be a petroleum refinery rig, it can be a jackup platform, it can be anything, is an offshore structure. All right. Third is dredging and harbor works. So to construct any marine structure, you have to primarily do either dredging or reclamation or any other kind of activity that is necessary. So this is a part of dredging and reclamation. I will tell you about a bit more detail about dredging and reclamation, that it's there in the coming slides. The second part is port and harbor structures or harbor structures. So under harbor works, you have something called port and harbor structures, right? So ports and harbors essentially help facilitate cargo movement. So a ship cannot come and stand beside the coastline or the beach just like that. It needs some sort of infrastructure to develop. So that is taken care in port and harbor structures. And the fourth part is marine power generation. This is a very latest field, especially offshore wind farms. This has come up in the past. The experimentation on it started 40 or 50 years ago. However, it is really taking pace now. In the past 10-15 years, we have come up with a lot of things on this. That is marine power generation, which is basically an offshore wind farm. It is pretty straightforward. The concept is very straightforward. The design, the implementation, execution is very complicated. So the idea behind this is, if you have moved to southern parts of Tamil Nadu, you will see that there are many wind farms that are created on land, right? So the best way of describing an offshore wind farm is that you take various windmills and you install them in deep to shallow sea. So because sea has a huge amount of wind energy that is constantly blowing, the wind farms there are very effective. And second is that you will not require any land allocation or you don't need to take or buy land. So it can be for kilometers and kilometers on the sea. and you can anchor them to the bottom of the seabed, and they will be generating energy for, as long as there is sea and as long as there is wind. In the middle, maintenance and all will come, right? The fifth part, this is a bit of a commercial part actually on marine engineering side, is essentially cargo movement. If you remember, I started off by saying that 2000 years back, point A to point B, we had to move cargo. So we used ships. That is where marine engineering came from. So the same thing, this is basically the today's seafaring cargo movement and inland cargo movement. So essentially cargo movement has to happen from point A to point B. And for that, you need ships and you need an entire commercial infrastructure around it, logistics infrastructure. And that commercial infrastructure can be in the form of logistics. It can be in the form of government policies, government investment, cars, trucks, buses, everything that is required, right? Because cargo on a ship is useless. Cargo has to come to your house. For it to come to your house, you need an entire logistics chain. So that comes under ship and cargo movement. All right. Now I have given you the definition, or my best understanding of marine engineering's definition of the 5 different types, right? So now I'm going to ask a very simple question to all of you, and please interact with me. Hello?
Maitra?
Yeah.
Before going forward,
yeah.
I congratulate you. Really, it looks very brilliant the way you are prepared and the way you are presenting. Great. I appreciate you. Great. Good.
Right.
Please carry on. Excellent.
Oh, thank you. Achha,
Yeah.
I thought there was a but coming somewhere. Okay.
No. Really, I want to appreciate you. Perfect. The way you have started, your way you are expressing, the prepared presentation, everything is perfect. Great. Please go ahead.
Thank you.
Yeah.
Now I have given you the definition or my understanding of the 5 parts, right? Now I'm going to pose a question to all of you, and please feel free to interact with me, right? So now, as civil engineers, what are the areas that we have to be primarily concerned about? Okay. And I would like some answers from you, and I'll go back to the previous slide. Right. So there is naval architecture and ship design. There is marine structure design. There is dredging and harbor works. There is marine power generation. There is ship and cargo movement. Out of these 5 parts, what is it that according to you is the most important parts for a civil engineer? So can anybody, interact or talk on this? Like you can guess.
Govind, Bhavani, Mohammed, please jump in. Let's make use of the session, please.
So there are no right answers or wrong answers. You can take a blind guess, no problem. I just want some kind of.
I think it would be a dredging and the harbor management. I think so.
Yes, correct. I think someone is messaging. I cannot go to the message screen. You have to speak up.
I will see and read order. One Samraj is texted is 2nd and 3rd.
2nd and 3rd is marine structure design and dredging and harbor works. Okay, nice. Anybody else wants to guess?
Sir, I guess all the 5 are equally important, but structural design will be more interesting and we have more part in it, I guess.
Yes, correct. So, okay, now I'll be just moving on. May I know your name, please? Who said the last one?
Sir, Govind.
Okay, hi Govind. Yeah, Govind, you're absolutely right about it. So marine structure design is one of the biggest focus areas for civil engineers. Okay. Now I'll do one thing. I'll come into the parts of the actual focus areas according to me, which I have now expressed. So first, as Govind said, marine structure design. If you go back to the slide, you will see marine structure design had 2 parts. One is coastal. Second one was offshore structures. Now for us, as civil engineers, coastal structures are the most important part. They are what the bread and butter of every marine civil engineer is, right? That's the first. The second is harbor structures. So harbor structures essentially will give you the entire civil infrastructure that is required for ship handling. So that is very, very critical again, right? These are the 2 parts on which I have basically gone in depth. And other parts are there. As someone said, dredging and harbor works. I think dredging and reclamation was exactly there in that. So that is also very important. And about that also I have a few slides, but the primary focus will be on coastal structures and harbor structures. These are the two most important parts that a civil engineer should know about, right? So the objective of the presentation is to give you the understanding on the following topics: coastal structures, harbor structures, dredging and reclamation, and fourth one I have introduced newly, and that is not mentioned anywhere, I have not talked about it, is survey and monitoring works. I will be talking about survey and monitoring. There are no specific slides on it. I want to talk to you on survey and monitoring because it is very straightforward, but people make it very, very complicated. So yeah. First, let us come to our first topic, that is basically coastal structures. Right? So coastal structures, if you have to see, essentially means that any structure on the coastline that helps you in protecting my shoreline, that is one. And second, ensures that my harbor area is not having very high waves. Okay. So when I move forward, you will understand it a bit better. But for the time being, just understand this, that coastal structures means that any structure that is along the coastline, and my two main objectives are: one, I am protecting my shoreline. There should not be any coastal erosion or shoreline erosion. One. Second, I am making the sea calm as ships come towards the coast. That is my primary objective using coastal structures, right? So there are three different types of, actually there are many types of coastal structures, but three fundamentals are seawall and revetment. Second is breakwater. Third is groins. Okay. Now, seawall and revetment. So these structures are essentially seawalls and revetment. It is very straightforward. The meaning of seawall is you're creating a wall along your entire coastline to protect it from any kind of erosion and any kind of wave attack. Straightforward. Now, once you make this structure, you can build roads on it, you can reclaim that soil, you can do anything you want, but this is the fundamental of seawall and revetment, right? Now, in addition to that, I have also provided here a typical cross section of seawall and revetment. So if you see here, can you see my mouse pointer by any chance?
Yes, visible.
Yes, right. I think the laser pointer is better, right?
And now
so
it's
if you
perfect,
see, yeah, if you see, this part is basically my revetment or seawall. Okay, and this is my land area. I have to protect this land area from wave attack. So I am just creating a barrier, and I'm creating a barrier which is multi-layered. So first, what I will be doing is I will be taking an excavator and I will excavate it in a slope, 1 in 2 slope, 1 in 3 slope, whatever slope. Then I will place a geotextile to retain that soil. Next, I will put a small graded soil, small stone layer, which is basically under layer. Basically, the gradation of this layer is going to be lesser. It can be 10 to 20 mm or say 50 to 60 kg rock. These kinds of gradations are used, and I will be placing it over the geotextile so that the geotextile does not get damaged, right? And on top of this layer, I'll be putting large rocks. This can be 3 to 5 ton rock. This can be 20 to 30 ton rock, any kind of rock based on my wave attack. So this will ensure that this coastline that is there on this side, or this shoreline that is there on this side, is not eroded and it is not taken away by the sea. So this is my basic fundamental of a seawall or revetment. It will protect my shoreline from any kind of attack, right? So this is a typical cross section. In the previous slide, I showed you 2 pictures, right? And the third is basically, if you see, there are 2 pictures here. Well, just a minute, I have to edit my PPT here. This image is overlapping. Right. So, yeah. So now, again, audience quiz or whatever you want to call it. This, can somebody guess where this part is, or what location is this?
Mumbai.
Yes, but specifically where?
Marina Bay.
Marine Drive. Yes, correct. So if you go to Marine Drive and if you walk, and this is my bay or whatever you want to call it, Arabian Sea Bay. So this part is the promenade on which there is land, and they have created a revetment here. If you see here, you will see large rocks here, and it will be at a slope of 1 in 2 or 1 in 3. And they have protected it with, I think here these are concrete blocks, which are tetrapods, about which I will tell you in the later slides. and on top there will be a flat surface. So if I take a cross section of this and if I show you, it will look something like this, exactly something like this, right? So this is the primary objective of a seawall. Now, once if I don't have this, then the sea will come in, and if I build any road here, it will be taken away by the sea. And that is the objective, and that is the construction of a seawall and river, right? Now, this is another example, same in Mumbai, but this is a under construction project, and I think they have commissioned it last week or something. This is basically the Mumbai Coastal Road project, right? So if you see, same logic. You have very big rocks that are placed. These are 1 to 3 ton rocks. Below that, there is an underlayer, which will be somewhere between, I think, 10 to 20 kg rocks. And inside that, there will be a core material, or there will be reclamation fill, which is nothing but very, very fine sand. And on top of that, below that, I'm having a geotextile or something. And on this side, I have my land. So the objective is, on this land, I'm building roads, and my sea will take away that roads if I allow it not to be protected. So this is the objective, and this is the construction, typical cross section and all that of a seawall or revetment. Okay. Now come to the second part, and this is a very interesting part. This is a breakwater. So essentially, a breakwater is nothing but, as you can see, it is the same logic of a revetment, but a revetment is only one-sided hard rock or one-sided big rock. A breakwater has slopes on both sides, right? So the idea of a fundamental idea of a breakwater is for any ship to come near a port or come inside a port, and for we to unload that cargo, because the ship is not coming empty. We have to unload the cargo. That is the objective of a ship. So for me to unload the cargo, the ship has to be stable. It cannot move left, right, up, down, and all that. So constant wave action. If you go to any beach, you will see that there is constantly waves are coming and hitting, coming and hitting, coming and hitting, right? So if there is constant wave action on the ship cannot be stable. The ship will constantly move in left and right, up and down in every direction. So for a ship to come inside and be stable, I have to stop that wave attack or that wave action. For me to stop that wave action, I generally use breakwaters. So essentially, if you see, the waves will come and crash against this part or this line. This area will be calm, and this area will have a lot of disturbance and turbulence. So if I build a terminal here, I can happily, load and unload my ship cargo. That is the fundamental objective of a breakwater, right? The next is a typical cross section. So it is very similar to a revetment, but I have slopes on both sides, and I am trying to, arrest my water flow and water scouring on one side. So basically, this is my wave attack side. From this side, waves are coming, right? So if this side waves are coming, I am going to provide big armor or big rocks here. There will be something like an underlayer here, and there will be a core layer, right? So my gradation or rock size reduces as I go inside. So on the top, I will have a rock size of say 1 to 3 tons. Inside, I can have a rock size of 0 to 500 kgs. It will be somewhere between 20 to 30 kgs, and inside I can have 0 to 10 kgs or 0 to 5 kg, very, very fine sand, right? Now, this is how a breakwater will look. Now, the thing is, now if you see, if you compare this cross section with a revetment, you will see that there is one difference, that you will have something called toe and something called scour protection. So what happens is, now this breakwater, now this wave will come like this, it will move in this way, it will crash, and then here it will turn like this. It will create a lot of eddy currents, we call them. It will be in this particular shape. So as the wave comes and moves like this, here after crashing, the water will come down and it will create a current like this. So this current needs to be stopped, or this needs to be properly reinforced at these particular locations, or else what will happen is this area or this soil will start scouring. It will just keep on eroding, and this entire part will fall down. So that is why we provide additional protection at the start or at the base of the breakwater, which is known as a toe. And there is additional layer allowed before or placed below the toe, which is known as a scour protection layer, right? So this is the fundamental, cross section of a breakwater, and the fundamental idea is that I am going to protect whatever is there on this side from wave attack on this side. Okay. Next, this is a typical construction stage breakwater photograph. So if you see, they have finished constructing the breakwater on this side, which is the sea side, and they are constructing it from the inner side. Okay. So generally the idea is that you cannot construct it from land. So you generally have many barges that are working together. So you have, if you see in the previous cross section, core is rock material, underlayer is rock material, armor can be concrete or large rocks. So everything is basically rock material at the end of the day. So all of this rock material needs to be fed using these kinds of marine barges. And at the end, you will have a marine barge which will have a crane which will be placing one after the other rocks, or one after the other armor layers, or concrete layers. So these things, or this is the typical plan view of a construction image of a breakwater. So now, yeah, this is an interesting part. Now the thing is, if you see here at the armor block, they have used a concrete layer, right? If I go back, here they have used concrete layer, here they have used rocks. Okay, so now this depends on site feasibility or designer's choice, but if it is concrete armors, you have some standard armor blocks. So these are various standard armor blocks, out of which I have used tetrapod. If you go to Marine Drive, you will see that there is tetrapod. There is something called acropod. Acropod, if you go to a breakwater called Dabhol breakwater in Maharashtra, you will find acropods. Stay bits. Sorry? Hello?
Sir, could you please explain about difference between tetrocard and rock? Actually, yeah, I have seen in tetrocard various. Ernakulam, Trivandrum, and Kanyakumari also. But
Right.
I want to know the difference
In tetrapod and rocks, right?
Yeah.
Okay. See, it is a very it is a detailed design answer. I'll give it to you, but try to understand it the best you can, and then if you have further doubts, I think you can call me personally and I can explain. But the fundamental logic is that if you see, a tetrapod is cast in a particular shape, right? Now when you are placing a tetrapod beside a tetrapod, that tetrapod's leg will fit here. Okay. Right. So because of that, now you will have 3, 4, 5, 6,000, 7,000 tetrapods in one line, where there is proper interlocking and lot of surface friction. Okay. Now, because of that, the resistance of a concrete armor block, especially tetrapod or acropod, is very high as compared to rock. Okay. So because of that, your tetrapod size, if you require a 2-ton tetrapod, the same thing, if you are putting armor rock, you will be requiring at least probably 6 or 7 tons. That is the size difference, because rocks will not interlock so easily. However, tetrapod is manufactured in a way that you can interlock it very, very easily. Okay. So that is the difference. So essentially the idea is that a concrete armor block will always be better than a rock, normal rock for armor. Okay. But sometimes it is costlier to make a tetrapod or costlier to make an acropod. Okay. That is why people go with rocks, normal rocks. Say if there is a quarry which is very close to the site, then what they will say is, I don't need to go for tetrapod. I will happily, blast the rocks and I'll get it. My transportation cost is very less, so no problems. But if your quarry is slightly far away and you can only order bulk in 2 or 3 times, then what we do is we order tetrapods, or we order, that time we go for tetrapods or acropods, because in that case, we don't need large 5 or 6 ton rocks, because I don't need a 5 or 6 ton rock for an armor. At that time, normal concreting gradation, coarse aggregate, fine aggregate, cement and all that is enough for tetrapod. So that is the reason we go for tetrapod, or that is the difference between tetrapod and rock armor. Okay.
Bhavani, thank you. Good, very good question. Very good question. Thank you, Bhavani.
Thanks.
Okay. Any other questions or anything?
You can go ahead. You can go ahead.
You can go ahead. Okay. I'll just summarize, Bhavani, what I said, because I know I said a lot of things. The primary focus is that tetrapods or any concrete armor block will interlock very easily. However, a normal rock will not interlock with each other very easily. So you need smaller size concrete armor blocks and you need very larger size rock armor rocks. So that is the reason you go with concrete armor over rock armor. Okay. So, okay. The next part is groins. So groins are very interesting. And if you see, groins are nothing but breakwaters that are constructed at 90 degree with the shoreline. Okay. So generally groins don't have any, commercial or industrial reason. Like breakwaters I will construct for a port so that ships can be stable. Sea walls and revetments I will construct so that I can protect my roads against erosion and all that. Groins are primarily built for environmental reasons. So what happens is that whenever you make any kind of coastal structure around a coastline, the sea movement or the seas, it is called as littoral drift. Basically, littoral drift is nothing but the movement of waves along this line. Okay. So because of this movement, you will have a lot of sediment transport that happens, meaning it will transport sand from point A to point B. That is what is littoral drift. Now, if I make a structure in the middle, then the top part will not get sediments. The bottom part, a lot of sedimentation will happen. So that now what happens is over the years, beaches in the down part of the structure starts getting eroded, and in the top part there is a lot of additional sedimentation that keeps on happening, right? Now because of that, my entire beach movement or my beaches environmentally that becomes a very big nightmare for me, because slowly and steadily my shoreline starts going back, and there is no natural nourishment of the beach that is happening from the sea. So to avoid that, what we do is we create these structures called groins. So now these groins, what they do is they trap the sediment in the lower end, meaning at one end. So for this groin will trap this sediment. This groin will trap this sediment. And over the years, what will happen is this entire area will be filled and it will become a very nice and stable beach. So for that to happen, we generally put groins. So in the next image, if you see, yeah, this is much more clearer if you will see. So if you see 1, 2, 3, 4, and 5 groins were built, and initially it would have looked something like this. Then over the years, it will be looking something like this. The entire groin gets covered with sediment, and the groin itself will go below the sediment. And because of that, you will have a very wonderful beach and shoreline that will happen. Now, this takes time, but this is a permanent solution, and this is a very common solution that is used across the world. So groins are one of the most important coastal structures from an environmental perspective, right? Now come to the second part. Now I have finished with coastal structures. The second part is harbor structures. Now coming to harbor, I'll just go back and I'll tell you where you are in the PPT if I have to go back. So I had told you about coastal structures and harbor structures. So I have finished coastal structures. Now we will be moving on to harbor structures, right? So harbor structures essentially is that any structure that is built at the junction of ship and land is harbor. Okay. Any structure built around it is a harbor structure. So you will see that a breakwater is also part of a harbor structure. Small boat is also part of small boat parking area or harbor is also a part of harbor structure. Jetties are part of harbor structures. Anchorage area is part of harbor structure. Everything that you see here is part of a harbor structure, right? Now, I'll tell you what these are one by one, so that I'll just tell you the definition of it. And all you need to remember is that a harbor has many moving parts that are simultaneously working to ensure that a ship will come from this part here, and then it will dock here, and then there will be cargo movement or cargo loading and unloading, right? Now, a few fundamental definitions here. Number one is a breakwater. So breakwater will ensure that no wave action is coming here, as I had told you. That is first. Second is a jetty. A jetty is a 90-degree projection that is created outside. Ships can come and connect themselves or dock themselves along the jetty, right? The third is an anchorage area. So anchorage area is basically the ships where they come and where they are stable, where they have left their anchor and they have, they have been attached with the shoreline, correct? Then there is something called as an entrance channel. It is very straightforward. Before you come into the anchorage area or before you come and attach yourself at the jetty or a wharf or any onshore structure, you have to pass through a narrow area which is called as an entrance channel, right? Then you have something called port facilities. Port facilities are nothing but various large cranes, or you have I think they are called, I'm forgetting the name. They transport the entire material of the ship from point A to point B. Yeah, conveyor belts. So you have many conveyor belts, you have many cranes, you have a lot of container yards, container stacks, cargo holds, and everything. So all of that is under port facilities. Then you have something called as a turning basin. So turning basin is nothing but a ship will come and it is going, while entering, the ship's forward will face towards the port. So exactly what you do to your car while parking, right? So while you are going inside the parking, you will turn the car 360 degree and you will park it in reverse. So the same logic is applied in turning basin also. So essentially what happens, a ship comes like this. Here it is turned 360 degree and then it is pushed into the anchorage area. So that is known as a turning basin. And okay, these are the fundamental parts that are shown here. In addition, if you see here, there are various cargo holds, like you can have a coal stack yard, you can have a steel stack yard, you can have container terminals and all that are created here, right? So all of these facilities come under a harbor. So various types of harbors have various types of facilities, but the fundamental is you will have a breakwater, you will have a jetty, you will have some sort of a wharf or some sort of a sea facing or car or ship docking facility. So the ship docking facility will be using mooring lines or some sort of things which will happen through a turning basin and it will come and attach itself. That is the fundamental that you need to remember, right? Okay, now coming to the details of the harbor structures. So first is piers and jetties.
Maitra,
Yeah,
you have 20-25 minutes.
got it. Yeah.
Yeah.
So harbor structures, first is piers and jetties, right? So the first is a pier. So anything that is projecting 90 degree with the shoreline, if you see here also, it is 90 degree with the shoreline, is a pier. So essentially, at the end of this, a ship can come and attach itself. Using various ropes, you can secure the ship, right? The second is a wharf. A wharf is nothing but it is, if this is at 90 degrees, this is at 0 degrees, right? So this length, a ship can come and happily attach itself here with mooring lines and ropes. It can, the ship will come and stand, and then the entire cargo will be loaded or unloaded. So this is a wharf. Third is a cargo terminal. So you have these massive cranes, right? So a ship can come and attach itself here, and these cranes that move on rails and everything will take out the cargo from the ship and place it directly over railways or directly over various trucks and buses. Okay. The third is container terminals. Now the same logic, a ship will come and with these cranes you will basically unload all the containers and you will stack them here, which is known as a container stack yard, right? Now why have I given you 4 different things: piers, wharves, cargo terminals, and container terminals? Now I have not gone into that depth, but please remember that a cargo terminal, a pier, a jet, a wharf, a cargo terminal, and a container terminal, the substructure and the superstructure loads are going to be completely different, and the way the structure behaves is also going to be completely different on each case. and the way it is analyzed for various loads, the way it is made, built, everything changes. So that is why these four categories are very important to remember and very important to understand, right? So anything that is at 90-degree projection, it is a pier or a jetty. Anything that is a 0-degree is a wharf. Now, a wharf which will handle cargo is a cargo terminal wharf. A wharf that will handle container terminal and for placing container stack yards is a container terminal wharf. Okay, so these are the four primary categories. Next, now coming to the additional information, we are at the end of nearly at the end of our presentation. So the first thing is dredging and reclamation. As I had started in the beginning saying that, who is like which are the parts that are very critical and important. After coastal and harbor structures, one of the biggest importance is for dredging and reclamation. So dredging is basically underwater excavation. Okay, so anytime if anybody tries to ask you what is dredging, if you take anything, even if you dive inside and if you take a stick and if you start digging below water level, it is dredging. So any kind of excavation that is happening below water level is dredging. Now there are two ways to handle that material that is coming out of the seabed. One, I go to a distant area and I just dump it because I don't need it. Or second, I can take that material and I can dump it in a way and create an artificial island. That is reclamation. Okay. So dredging. Now the first thing is dredging from a civil engineer's perspective. One, you have to understand this, that dredging involves underwater sediments. It is essentially important to create waterways for ships. So if I have to go back to this part, right? So for a ship of this size to come and attach itself here, it will never get a water depth, correct? Because if you stand near the beach, hardly your knees will go below water. So natural water level at the shoreline is very, very less. But if I have to dock a ship whose size is bigger than 2 or 3 times bigger than Eiffel Tower, then the depth of the ship is in the range of 15 or 20 meters below the water level. So for me to ensure that a ship can come from this deep sea, it will come inside and it will anchor here. I have to ensure that this area is excavated below the water level to provide my ship with access. And that is my fundamental requirement of dredging. Okay. Now in that, this is create. Now there are 3 types of dredging. One is known as capital dredging. Second is maintenance dredging. Third is dredging for reclamation. Capital dredging is I do not have water or I do not have access depth. I am digging more and more and more below water level to get to a desired depth so that my ships can come in. So that is capital dredging. Essentially digging underwater till I get depth for which ships can pass. One. Second, now after I have done that, every year there will be monsoon. Every year there will be sedimentation that will happen. So I have to ensure that my depth is maintained at that level. So every year I have to do dredging. So that is called as maintenance dredging. Number 3 is reclamation dredging, which is basically I take material from one part of the seabed, I bring it to the place where I want to create a new island or I want new land, and I will dump it there to get new land. So these are the 3 types of dredgings. Now, in addition to this, dredging happens primarily with the help of something we call dredgers. Okay, dredgers are nothing but specialized ships that have the ability to cut underwater seabed, and push that material, suck that material from there and push it to a different location. Okay, so I have included 2 different types of dredgers. So these are essentially ships which are modified. Yeah.
Maitra, actually, we can see only the dredging slide. It's about
I'm at dredging only. I'll be moving on. Just one minute.
Yeah. Okay.
Yeah. Right. So, okay. So sorry, I lost my flow. So yeah. So as I was saying, types of dredgers, right? So in dredgers, we have various types. The 2 most common types are, one is a cutter dredger, which is essentially, if you see, this is the ship. It will have a cutter head, which will cut the seabed. It will suck that material out, and through this pipe, it will push it to a different location. Okay, so this is essentially hydraulic dredging that happens. The second is nothing but excavator dredger. Very straightforward. You have an excavator which is attached at the end of a ship. Now, this excavator generally has a massive bucket capacity. So the bucket capacity of this excavator can be between 20 and 30 meter cube. So this is a very, very big excavator that is placed, and the boom size can be as large as 40 or 45 meters, right? So essentially, I am digging and digging till I get to the required depth, and I am moving this material out. Now, cutter dredgers have one big advantage, that the material is pumped out through this pipe, and however long I want, I can create the pipe. The excavator dredgers has one big drawback, that it will take the material out, and just in the case of land constructions, how you will take an excavator will excavate, and then it will put on a dump truck. This material is placed on a barge, and that barge then moves it. So there is a constant movement of barge that happens for an excavator dredger, and a cutter suction dredger will constantly keep dredging and constantly keep pumping material out. There are also various other types of dredgers. One important dredger is something called as a trailer dredger, for which I have not shown here because it is not very commonly used in India. But cutter dredgers and excavator dredgers, you will come across much more. Right? Now come to reclamation. So I think on reclamation, there is not much to be said. It is a very, if I have to go in depth here, it will become very boring, and it will be a lecture on geotechnical engineering. I don't want to do that. So the basic understanding or basic logic is, as I was saying, that dredging, there are three parts: capital, maintenance, and for reclamation. So if I have dredgers that will pump material out onto a particular area, and I will create an artificial island, right? So that is essentially how reclamation works. Now, if the ship shown here is actually a trailer dredger. So what happens is, a trailer dredger will have a massive capacity in its own, where it will store a lot of material that it gets from the seabed. Okay, and using various pipes, it will then pump the material out and create these kinds of islands. So one of the most, I think the most famous reclamation project in the world is Palm Islands, and this is the method in which it was created. This method is specifically called rainbowing, in which material is pushed from the front of the dredger. Now, there are also 2 or 3 other ways in which material can be pushed. For example, the bottom of this dredger or bottom of the ships completely opens up, like it will become completely open, and the entire material that is there inside this will fall down onto the seabed, right? That is one. Second is, there is also similar this kind of pipe that it has a pipe on this side. So it will keep on taking this material out and pumping it through this particular outside part. This is known as side casting. So these 3 methods are generally employed by trailer dredgers for reclamation. Now, instead of trailer dredgers, if you have something like this, like a cutter dredger, what it does is it will keep on dredging, and wherever this pipe is ending, their material is being pumped out. So that material, if I take that side of the pipe and if I push it here, then constantly it will keep on reclaiming the soil. So the most effective way of reclamation is using cutter dredgers, but cutter dredgers have one drawback: they cannot work in deep sea, or they cannot work in wave action areas where it is prone to wave action. So, and those locations, you either need to go with a excavator dredger or with a trailer dredger. So that is why many times you see that trailer dredgers are used for reclamation works, right? So this is all about dredging and reclamation. Please ask me more questions on it, because I have just given you a very brief understanding of dredging and reclamation. And the next is the challenges, right? So fundamentally, there are many challenges in coastal engineering. The biggest are the 3 are erosion and sedimentation management. So the most critical aspect of coastal engineering is that there is a lot of erosion and a lot of sedimentation that happens. So if you leave the sea as it is, and if you leave the shoreline as it is, the sea will keep on attacking and it will keep on taking away the material. So this is one of the biggest problems that you will face in erosion, in coastal engineering, because the moment you create a structure, the sea wants to break that structure and take it back to the sea. So protection against erosion is very important. Sedimentation management essentially is the moment I create a harbor, and if I excavate it till say -16 or -18, sea will come, it will keep on doing, it will keep on doing sediment transport, and it will keep on filling that area till its original level. So you have to keep on excavating, keep on dredging to maintain the levels at that location, right? Second is sea level rise and climate change adaptation. Now, I don't know if other parts of civil engineering are as affected by climate change or not, but in marine engineering, climate change and sea level rise is a very real and a very big issue. So because any structure we build generally for 100 years or 150 years. So now it becomes very difficult for us to fix the level of the structure, because if the sea level keeps on rising at the rate at which it is rising, then the entire structure may go underwater in the next 50 to 75 years. So sea level rise and climate change, adapting to climate change is very, very important. And for any long-term coastal structure, you have to take into account sea level rise. And it might seem very fancy, or it might seem like it is not happening. It is definitely happening, and we have structures that when we build for 100 or 150 years, we raise the level sometimes by 3 or 4 meters, which is a very massive amount of money that needs to be spent, but to accommodate for sea level rise, because it is expected that probably a lot of the structures can go underwater, right? The third is coastal flooding and storm surge mitigation. Now, this is another byproduct of climate change that is happening, is the storm surges, or these are known as cyclones in India, typhoons in Japan and US. Essentially, what happens is, due to climate change, we are seeing a very heavy frequency of cyclones that are coming up. And the intensity of the cyclone has also increased a lot. And because of this, you have a lot of coastal flooding during the cyclonic period, where a massive amount of rain just pushes the amount of water inside your coastal structure, and your coastal structure has to survive that. And the second part is wind. During cyclones, winds of 250 or 300 kilometers per hour will be constantly hitting your structure for a period of 6 or 7 hours. And add the fact that this wind is blowing over a very, very rough sea, so there is going to be immense wave action on that. So designing your structure for this and ensuring that your structure is resistant to this is very, very critical and very, very important, right? Next part is challenges to harbor engineering. One, as I said, dredging techniques and sediment management. So dredging, understanding what is the rate of sedimentation, and ensuring that you mobilize your dredging crafts or dredging vessels to ensure that your sediment management is happening properly. Second is port infrastructure management. So to ensure operational efficiency, you need to ensure that port and infrastructure maintenance works happen at regular pace, because once built, it is very difficult to maintain these structures. So every 5 or 10 years, you need to definitely go and check the health of the structure. And if there is any change or any slight deterioration, you cannot take it lightly. You have to take it very, very seriously, because any small deterioration, if it happens, the sea is not going to forgive you. The sea is going to keep on hammering till it breaks. It is not like how a structure, a normal crack happens and we can say, okay, fine, we'll apply some sort of it, or we will completely ignore it on land. On sea, the marine environment is very, very brutal. So any small crack, any small deterioration, any small rusting needs to be immediately attended to. There is no exception to it. There is no two ways about it, right? The third part is navigation safety and vessel traffic management. So as a civil engineer, you don't actually get a lot of details, or you don't have to worry about this. So navigation safety and vessel traffic management is nothing but your traffic system and management systems at sea and around port areas. So I think a few years back, I think someone messaged something.
Yeah.
Can you?
Dinesh, 1 minute. Maitra, actually, you just carry on. We have last 5 minutes for you. You finish it up, then we can take up questions.
Yeah, sure. So basically, vessel traffic management is essentially around a port area. You will have a lot of vessels that will be moving here and there, and for that movement, you have to ensure that you are managing everything just like how aircrafts are managed using the air traffic controller at an airport. So that is essentially taken into account in navigation safety and vessel traffic management. So sustainable practices, I think data analytics and remote sensing is one. Second is emerging technologies in marine engineering. You have AI and ML and sustainable practices. There are many. I'm not getting into depth of it. The thing is that how AI and machine learning is changing everything. Robotics, remote sensing is changing everything in the current world. It is also impacting the marine engineering field more than anything. So it has given us much better understanding of seabed, much better understanding of traffic management, much better understanding of coastal structures, how it behaves. Like as computers are getting more and more powerful, we are able to simulate the actual actions at sea using a computer, which was not possible before. Even 20 years back, it was not possible. Right now, we are getting these things. So it's a very new field, and it's very, very interesting with respect to this. I had planned to show a case study using Google Earth. So should I go ahead with that? Or should I stop?
Okay, Maitra, what we can do? No, you just hold on the case study for a few minutes.
Right.
Before that, guys, um, uh, I want to take few feedbacks from you all. So you can unmute and tell you we have a case study which is there. So before that, I want to have your feedbacks. Please unmute and let me hear 2-3 feedbacks how Maitra has given this session. If you want, it's up to me. It was well measured and well placed on time. Really a perfect Maitra. What I could call you are definitely are going to be a shining star in the civil and marine industry, and
Thank you.
a great applause for you.
Thank you. Thanks a lot.
The content which you have prepared, the way you have presented, the conviction and confidence, how you are having perfectly. I want to quote 2 lines which you have said. I really enjoyed it. The ship can happily come and join on the dredge, no, the jetty or the wharf. That line was very interesting. The ship can happily come and settle down at the wharf. And the last, when you're talking about the sea is not going to forgive at all. It is going to hammer you.
Right.
And those are very interesting. It shows how much you are blended with your passionate with your job. Good,
Right.
great, congrats, and very much happy to have you here. And we will keep on disturbing you. We won't leave you for that.
Sure.
Thank you. Can we have other feedbacks, please? 2-3 feedbacks, then we can have the case study session.
Yeah, Maitra, thanks for coming. A word which we explained, and you put lot of effort. I think you remember me. I'm
Yes,
Dinesh.
yes. Hi, Dinesh. Hello. How are you?
Yeah, hi, and hi, fine, good. The way you presented, it's fabulous. It's fabulous. I think people can understand many things about the marine engineering. I know personally. We met personally, so I
Right.
know you. Also, people, they want give to some feedbacks about your presentation. It's really fantastic. People who don't know the marine engineering and the details things, they came to know what is marine engineering right now, and it is
Thank you.
fabulous. Thank you so much.
Thank you.
Can we hear from some 1 or 2? And there are feedbacks on text also. Sridhar has posted that both the content and presentation are really good and informative. Thank you. And Malik has posted this is perfect.
Thank you. There is a question there.
Yeah, I will take up the question. Before that, I want to
Okay.
hear from the audience. Yeah, can I hear 1 or 2 feedbacks? Guys, we want your feedbacks. Govind, Bhavani, Karan, Umapati. Are you there?
Question was especially on presentation.
Karan, you are not clearly audible. Karan, we can't get you clearly. Karan? Karan, you are not audible clearly. Sorry, Karan. I think there is some audio issue, but thank you for thank you for trying to connect to us. Thank you. Bhavani, you can speak.
Yes, sir. Actually, as Rajendran sir said, really amazing session as well as, I mean, you will be the very good signing star in your future in the same industry. Actually, this kind of, presentation, stimulating us. I mean, we have to do something. I mean, if people are doing much better, actually definitely this. Now I'm planning to do some kind of things, and we have to learn such a things. More and more. So you will be the signing star. You're very amazing. You have done superb, and way of approaching and way of presenting. It's a very amazing. That's
Thank you. Thank you.
good. Thank you so much.
Thank you, Mr. Bhavani. Thank you.
Yeah, can I have from any one more? Then we could go for the case study. Govind has texted, excellent session, sir. Content-wise, presentation-wise, everything is perfect. Your passion towards your domain is wonderful. Keep the work. Good work. Yeah. Then okay. Then Maitra, we can take up the questions, and I think the questions would be better than going for case studies. Okay. Karan, yes.
Sorry, can you help me hear me?
Yeah,
Hello?
please. Yeah, Karan, please, you can.
It seemed the session was very good, sir, but I have missed some of the slides over there. But while listening to the session, you came to at night. You came and gave the marine engineering topics good. It is a very informative session for us, and it will help in our industry also to handle with clients and keep going on with your work, sir. Thank you.
Thank you, Karan. Thanks a lot. Yeah.
Thank you, Karan. Okay, let us take up the questions. So the question, Arun Kumar has posted few questions. One is that, can you explain how CIRA will be helpful in die construction?
Is it CIRA or CIRI?
Arun Kumar, are you there?
Yeah, yes, I'm.
Yes, you can ask your question. Yeah, please.
Yes, CIRI, Sira book, code book for.
Syria.
Yeah.
Acha. Okay. Syria C603. Okay. So essentially, Syria is a rock manual. Okay.
Yes.
So Syria rock manual essentially gives you the design parameters of the entire breakwater revetment and all that. Okay. So we use it for design. That is one. Basically, when I say that I am going to use a 2-ton tetrapod or 4-ton tetrapod, or I'm going to use a 5-ton rock or 6-ton rock, there is a calculation behind it. It is based on Hudson's formula. Okay. So Hudson's formula is based on wave height. So basing on the wave height, how much force will come, and based on that, I will decide my rock size. So it will hit, the rock has to sustain. So when it hits, the rock has to sustain. So now this correlation is given by Hudson's formula. Now that Hudson formula you'll get in Syria. That is in chapter 5 of Syria. Okay. Second is you will find the top layer, armor layer and under layer have to sit properly, or else the water will go in and the under layer will slowly erode away. So for it to sit properly, there are specific ratios: permeability, internal stability, and all that. Those ratios are there. Then those things are there in chapter 5, which are design parameters. From execution point of view, there is something called chapter 3, which is on materials. So materials will help you to understand this gradation when you get, right? So when you're getting the rocks from the quarry, you need to have it in a specific gradation. So 10 to 70%. If you have done geotechnical engineering, if you have done in 4th or 3rd year, they generally have. There is a graph, optimum moisture content and all. So that entire S curve and everything, Ross-Ram equation and everything is there in Syria, chapter 3, materials you get. So it's a very open-ended, it's a very big question. I can't specifically focus it. And now you're asking in dike construction. Dike is nothing but a breakwater. Okay, so dike will not allow water to take the material out. Okay, so dike and breakwater, the concept is the same. So for it to have it, you will have to go to Syria and you have to do the design. So Syria essentially helps you in materials, which will help you in execution. Chapter 5 is on design, which will help you in getting the values.
Okay. And one more thing, what is mean by flow training dike?
Acha, are you from Kudankulam somewhere?
Yes.
Acha. Okay. See, flow training dike is specific to Kudankulam project. It is not there in other projects. Okay. So Kudankulam, in Kudankulam, what is there is you have some sort of outlet that is happening. Okay. So water is going to be pumped out of the structure that is there. Now the water which is being pumped out is at a higher temperature than at the other areas. So we cannot allow the mixing of hot water and cold seawater because that will impact the cold seawater. So in the middle, they have created something like this, a dike. Okay. Yes. And so the hot water will go and then it will start moving in both directions. So that is the reason it is called a flow training, because it will flow in a particular direction. So that is why it is flow training dike. So there is it is flow training dike, FTD is specific to Kudankulam. It is not there anywhere else. Okay.
Okay. And one more thing, this griones, whether it will develop the beach? Huh?
Yes, it is used for developing beach. Yeah.
Because in Pondicherry, I have seen this griones where there is no beach, and now it has found a beach. And then in North Chennai also they have made a griones to prevent the erosion.
Okay. Nice. Good. Okay.
Then we have a question from Sridhar. Sridhar, are you there? His question is about mention eddy currents and protection against scoring due to the current in the case of breakwater. How do we manage the same in seawall, where the currents are less intense there?
Sorry?
No, due to eddy currents, the scoring will happen in breakwater. So, whereas in the case of seawall, you can see the question. Yeah.
Okay. Eddy currents and protection against scouring due to currents in the case of breakwater. How do we manage?
Are you there?
Same in seawall?
Yes.
Whether the same...
You can ask your question, sir. You can ask your question.
Yeah.
Is it clear, sir? So we are protecting the...
See, scouring will happen in both cases, okay? Whether it is seawall or whether it is breakwater, you will have scouring, okay? Now, currents being less intense is very difficult to say. It depends on the wave action over there, okay? Now, the place where I showed, in Mumbai Marine Drive, I showed you a picture, right? There, the wave height is, I think, 1.2 or 1.3 meter, okay? Now, the same if you go to other parts of the country, now that is a shoreline, it is 1.2 or 1.3 meter. Now, if you go to other parts of the country, say in Visakhapatnam, or if you come south after Chennai, if you go towards Pondi, in the middle, you will find that wave height increases to 2 meters, 3 meters also. So eddy currents will completely be depending on the wave height at that location, which is completely arbitrary. There is no way to predict that, okay? So it is better to, get the data of that location of the site that you're working on, and then you will be able to define whether there will be eddy current or scouring at all. So there is no thumb rule that seawall it will be less, breakwater it will be high. It can be other way also. It completely depends on the wave action at that location.
Yes, thank you, sir. So why I asked this question? So in the images shown, That is specifically we have given the design for the pouring resistance. In the case of
Yes.
water, I mentioned it. Sir.
Okay. See, if I take you back to the reclamation, no, there will be additional protection below, like this. The breakwater, the revetment also came down and it had a below part. That is your scour protection in a revetment. Again, the cross section that is shown, no, for the revetment, it would be for a less intensity location. It is not because breakwater will have high intensity or revetment will have. Okay.
Yeah, thank you.
Yeah.
Okay, I think we could take up only one more question.
Sir.
Bhavani, please.
Yes, sir. Sir, actually, how we are using artificial intelligence in marine engineering? One first question, sir. And second one is which type of material we are using for the pouring? I mean, as told you, I mean, for artificial island, we are pouring one material. I think I didn't get the name. Actually. So, two questions. What is the role of artificial intelligence and that particular name?
Okay. See, I'll answer the second one first, then I'll go to the first one. So,
Please.
the material that is being used depends again at the location. It depends on the designer. Generally, I have seen 0 to fine grade soil. So it will be somewhere between say 10 to 50 rocks. You can definitely use for creating islands. Okay, 10 to 50 gradation size rocks you can use there. That is one. So very fine sand. Okay, and even 0 to 500 kg rocks also may be used. So it depends on the availability of quarry availability and all. But if you really have to go, I think 10 to 50 rocks, that will be my standard answer. Okay, you can never go wrong there. Actually, Arun Kumar was asking about Syria. Syria gives you the gradations of what kind of rock can be used where. So 0 to 10 to 50 is one of the standard gradations we get from Syria. So we use it.
Sir, can I take 10 to 50 right?
10 to 50 yes.
Okay.
Okay. See, for better understanding, you can refer Syria, CIRIA C603. This is a code book which is available and it is known as the rock manual. Go to chapter 3. In that, it will give you for core, for underlayer, for armor, what are the standard gradations that are available.
Okay,
so,
6360.
C603.
Okay.
Okay, so that is a much more, like me guessing is bad. You going there and seeing it is much better. Okay. Second is you asked me about AI. Now, artificial intelligence, I think. Okay. Now, artificial intelligence, I think 2 or 3 places it is very useful. First is, see, any kind of software, design software that we have today, right? For say bridge analysis, building analysis, any kind of structure on land, the loads are very, very standard. There are code books for the loads. Okay. For wind, I can go to IS 875. For say RCC structures, IS 456. For this thing, bridges, IRC 6 is there. All of that is there, right? But for my codes on C, there is no standard there is no standard code or anything for force calculation. Like they have given some random equations, like Hudson's equation is there, some equations are there, but they are not based on theoretical data. It is not like calculated equations. It is based on empirical data, meaning they took 2000, 3000 waves, they then took the data, they then created an equation like that. So artificial intelligence can, because, and this is happening because the number of forces or the amount of interaction with C is so massive, you cannot design it, you cannot bring it onto a software. It is not possible. So artificial intelligence, machine learning is making it useful from a designer's perspective, that I can actually simulate the conditions of C, because artificial intelligence more than artificial intelligence, machine learning is the part which actually will help you, because the way C is analyzed, or C structure interface is analyzed today, is using CFD, computational fluid dynamics. Now, computational fluid dynamics runs a lot of data inside. It will take the wave data, wind data, it will take tectonic movement, it will take the topography data, bathymetry, a lot of data it will take. So this is, all of this compilation, artificial intelligence helps a lot. So that is one place where there is a lot of scope.
Okay.
Okay.
Thank you, Bhavani. Dinesh, I think you can,
Sir,
give a
sir,
thanks, a vote of thanks. Yeah,
Sir,
Bhavani.
Rajendran, sir,
Yeah.
actually, I'm requesting you. Next session, if you can take a role of artificial intelligence in construction industry.
Next session. Oh, okay, we will consider. Thank you.
I'm requesting you, sir.
Yes, Bhavani. Thank you. Dinesh Babu, I would request you to give the vote of thanks. Yeah.
On behalf of Concrete Study Circle, it's a lot of pleasure, and very thankful, heartful thank you for you. Now we have given you very short time in your busy schedule, and you have done a
Sure.
lot actually. On behalf of Concrete Circle, yeah, we are very happy, and you will be here, and we will be disturbing you a lot in upcoming season also. So we want to give another session, regarding how the civil engineer should, what is scope in the marine engineering kind of a thing, so people can understand for that. Thank you so much. Thank you so much. No words to explain, and the way the presentation, it is obviously fabulous as you are.
Thank you, Dinesh. Thank you.
Maitra, you are always welcome to Chennai. Here you have your friends and brothers here. You are most welcome to Chennai, and we will be waiting to catch up with you.
Definitely, Rajan. I'll be there. I have actually stayed in Chennai for 4.5 years, so no issues there. I will be back sometime, and I'll definitely give you a call. Right?
Sure.
Yeah.
Thank you. It was very wonderful. Very wonderful. Thank you. Thank you so much.
Thank you so much.
Yeah.
Thank you. Thank you.
Thank you, sir.
Guru, what's it? What did you?